Alright, very good morning. Today we will start chapter 3. The reason I yet to upload tutorial 2, tutorial 1, sorry, because not tutorial 1, I mean regarding tutorial 2 and 1, because we still have one more tutorial for section 6. Once I finish that, then I will upload tutorial 2. Not tutorial 1, I have already uploaded tutorial 2 for the logic. All right, now chapter 3, combinatorics. This combinatorics, those who took ATMATs in the school, you are familiar with permutation, the formula NPR, something like that, and combination, that is NCR. Okay, those who didn't take ATMATs, don't worry, I will start from the scratch to teach all these things to you. Okay, now let us start. Before we start combinatorics, we have to first know the idea of factorial, the factorial notation. Okay, what is this factorial notation? Very easy, you can read this one on yourself, or you just remember like this. If it is 5 factorial, you start with 5, multiply by 4, multiply by 3, multiply by 2, multiply by 1. So you have to go all the way until 1. So if you do this, if you press this in the calculator, okay, in the calculator there is one sign there. If you can find, okay, you can find one sign there like this, okay, like this. If you press this, there's one sign like this, exclamation mark, okay, this mark here. 5 factorial, you will get 120. Okay, how about 4 factorial? 4 factorial, how you can write? You can write 4, 3, 2, 1, and you press this, you will get the answer here, which means this is 4 factorial. This one here is 4 factorial. So 5 factorial, I can write it as 5 times 4 factorial. Or what is this? This is 3 factorial. So I can write 5 factorial as 5 times 4 times 3 factorial. Depends on the question which way you want to write this. Okay, now for example, this one, five factorial. Just now I teach you 5, 4, 3, 2, 1, or you simply press in the calculator. As I told you, there's one sign in your calculator, you can find that. Those who are using this the black and white calculator, it tells that class V's. I'm using that calculator. The button is, this button is in above. If you see, can find this symbol here, it is above here. Okay, down here there is the kurungan, the bracket, okay, in between 8 and 9. So this I'm talking about this notation here. You have to press shift, this one, press 5, press shift and press this one, you will have this one and you will get 120. So that's how you use calculator to find the factorial. Okay, if you want to do manually, you have to press like this and then you have to calculate, you will get 120. Okay, that is one. Okay, don't worry, all these are recorded. Later I'll send you the recording. Even though I erase, you can still see in the recording. Now 7 factorial divided by 6 factorial. So 7 factorial, how I can write? Like this, and then divide by 6 factorial. But then you can see that, as I told you, this whole thing this whole thing 6 5 4 3 2 1 it basically is 6 factorial. 6 factorial. So instead of expanding the whole thing, okay, you want 6 factorial so that you can cancel each other. So I want to write like this: 7 factorial. Just now I expand 6 until 1, isn't it? That is actually 6 factorial. Divide by 6 factorial so that I can cancel. I have only 7. Now here what I want, if I can expand until 8 until 1, I can expand that, I can times, I can write in the form of product. We call that in the form of product of 8 times, 7 times, 6 times, 5 times, 4 times, 3 times until 1. But like we did here, we need 6 factorial so that we can cancel. Here we need 5 factorial, so I can write 8 times 7 times 6 times 5, but instead of expanding this I put a factorial here. That's it, because if I expand that I will get the factorial. This is manual, manually you can cancel, then you will get 3 3 6 for this one. I can do, of course all this can be done in the calculator. I'm just showing you how to do manually. That's the thing. This one I focus here. Okay, 5 factorial we cannot do anything, just leave it. 52, 51, 50, 49, 48, 47. This 5 factorial, no need to expand, just leave it like that. Okay, and then but then the 47 here also we are going to leave it like that because we can cancel. 47, this one. Now this is, once you cancel, then you press in the calculator, you will get 2598. Of course you guys might be thinking, why not we press everything in the calculator? But yeah, can. It's just I'm showing how to cancel each other in case, because sometime in the question you won't get a number, you will get some in terms of n, something like that, so you can cancel. Okay, later we will see if there's any question. Okay, this is the first exercise we did here. Okay, yet to go into the combinatorics. Just we are going to use this in later part in our combinatorics. Factorial notation, this one. All these exercise. Now I give you some time. Okay, I give you some time. Get me these answers first. You can press in the calculator or you can use do manually. Okay, 0 factorial is actually 1. I already write here. Okay, 0 factorial is not 0. 0 factorial is 1. 1 factorial also 1. Okay, 2 factorial is 2 times 1 becomes 2. 3 factorial is 3 times 2 times 1, which is 6, and so on, go on. Okay, I give you some time. Okay, I give you some time, maybe 5 minutes. You can press your calculator or you can do manually. Try to get this answer, then I will write the answer here. We will check. In the calculator, I'm having the class Viz calculator. Class Viz. The Casio FX5EX. So now, I suppose you guys found this notation, X. Okay, I think it is, you have to press shift and press this. So how to calculate this? You press 6 and then press shift. In my calculator here, it is on top of this button. So press 6, shift this button, you will have 6 factorial there. Do you have this? Can you guys get this? Do you guys get 720 here if you press this in the calculator? Yeah, okay. Do the same thing for the rest. Maybe for the rest, I think you have to put a bracket first and then divide like this, or you can put, I mean, I leave it to you, okay, as long as you guys can do this. So if you do this, your answer for the next one is 10 here. Okay, in your calculator you can press this as 10 over, there's a function if you use the one class Viz like this, or if you want to put it in a bracket, I prefer you to put in a bracket. Okay, you can get the same answer. Next one you get 720, this one you get 20, this one is 1140. Okay, this should be the answer you get. Okay, hope all of you get this answer.
Yes, yes, doctor. Yes, doctor.
All right, now let us move on to the next slide. Counting principle. So what is counting principle? Okay, counting principle can be divided into two counting principle. One is sum, one is product. I will explain to you, both I will explain to you. One is sum, one is product. So we are going to do sum first here. Okay, hasil tambah, sum, hasil tambah. All right. Suppose that we want to buy a computer from one of two makes. Okay, let's say Lenovo or Apple. This is Lenovo. This is Apple or Mac. Suppose that we want to buy computer from one of two makes. Okay, Lenovo. I just, instead of Apple, I just put Mac then. Suppose also that those makes have 12. Okay, Lenovo got 12 laptop, Mac got 18 type of different models, different models of laptop. Let's say, for example, then how many models are there altogether to choose from? Okay, okay, you napile, you want to choose, you want to buy a laptop and you see 12 Lenovo laptop and 18 MacBook, 18 types of MacBooks altogether. How many option you have? Okay, how many pilihan, how many models are there altogether to choose? What you have to do? 12 plus 18, you have 30 models to choose from. Okay, that's why we plus here, we plus some principle. So out of 30 models you have to choose one. That's the idea. Okay, hope all of you understand this. Very easy. Out of 12 Lenovo models, you go to a shop, you see 12 Lenovo, 12 Mac, so you have freedom. You have to choose, you can choose whichever laptop you want. How many laptops are there? 30. 12 plus 18 is 30. That's why we call sum principle is one. Okay, next, this one you can read or you don't want to read, up to you. Just try to read and try to get a general idea. Okay, if I read this, then you guys get bored. You go through this one. Same idea here. Now, product principle. A computer manufacturer now offers 5 different CPU. Okay, CPU, 4 different RAM and 3 different capacitors of disk. 5, 4 and 3. How many different choices of computer are there, assuming that everything else? So now one computer, if you want to choose one computer, that one computer must consist, in this example here, that one computer must consist one CPU plus one RAM plus one disk. So one computer consists of one CPU, one RAM, one disk. Okay. Now if you want to choose, if they have 5 CPU, 4 different RAM and 3 different disk, then how many choices you have now? Basically what you have to do, CPU, you have 5. For each CPU you have 4 different RAM. For the 5 CPU, for each CPU you can combine with 4 different RAM for each CPU. Okay, this one is 5. Now this is RAM. And then for each RAM you can combine with 3 disk. So if you, of course I don't have enough space here, but for each one of them you do this, how many combination will be there? Basically you're going to have 5 times 4 times 3, altogether will be 60 different computer you will have. Okay, That's why we call this as product. So our chapter today, combinatorics, we're going to use this type of plus and multiplication kind of computing techniques to get the number of arrangement or order. The first one was plus. Out of 30 computer, you can choose one. The second one was you have to multiply because each computer consists of CPU, RAM and disk. So one computer you need all together CPU plus and RAM and disk. Okay. So that's why n means you must have. N means you must have. Okay. So this is the idea behind product here. Product principle. You multiply all, you get 60. Okay. This one you can read yourselves. Let us do some exercise here. A committee is to be chosen from 8 mathematicians, 10 physicists and 12 biologists. If the committee is to have 2 members of different background, how many such committees can be chosen? So now I can choose either maths and physicist, here physicist, or I can choose maths, biologist, or they want only 2 members from different background, or I can choose between physicist and biologist. These are the all combination. Of course, you can if you want to interchange, you will get the same thing. M and P and M are same thing. So in this case, how many mathematicians are there? 8. When you see an AND here, this is AND. And if you see an AND here, you multiply. How many physicists are there? 10. If you see an OR here, you plus. So that is the idea. OR means plus, N means multiply. How many mathematicians? 8. And biologist, physicist 10 and biologist. If you calculate this, you will get 296. That is the answer. I give you maybe 1 or 2 or 3 minutes to have a look, and you want to copy this, you can copy this first. All right. Sri Mangi's restaurant serve 8 varieties of fried rice, 7 varieties of noodle, 10 varieties of cold drink, 9 varieties of hot drink. How many possible choices are there if the customer want to take a meal? Meal means makanan saja. Meal means makanan. How many? What is the makanan? I mean fried rice and noodles. So if he want to take a meal, how many options he have? 8 plus 7. Daripada from 15, from 15 meals, he can choose anything he want. Have a drink. How many drinks are there? 10 plus 9. So you can choose out of 19 drink, you can choose one. Take a meal or have a drink. Okay, he want to eat or he want to just have a drink. So altogether how much? Fried rice, noodles, cold drink, hot drink, altogether 34. Take a meal and have a drink. So this is where the tree diagram comes into the picture. If he want to take let's say there are 8 fried rices, isn't it? So you have for meal, how many you have? 15. You have 15. You have to draw like this. 15. This is meal. Let's say this is fried rice, kampong fried rice. This is kampong fried rice. 8 types of fried rice. This is kampong fried rice. For each kampong fried rice, he can choose how many drinks? 19 drinks. So you must have draw this 19 times. For each, for one kampong fried rice, he has 19 option. How many fried rice and noodle are there? Here, 15 times 1 is 19 drinks. 15 food, I mean 15 meals you have, multiply with 19, you will have 285. I repeat, so when they say take a meal and have a drink, this is the multiplication. N means multiply here. For each meal, for kampong fried rice here, you can find any one of the 19 drinks here. Let's say this one is maybe chicken fried rice. You will have another 19 drinks for you to choose. So that much of option you have. So altogether, how many options you have? 285 options you have when you combine meals and drinks. Order 2 fried rice and means you multiply on. Order 2 fried rice. 2 fried rice, you can repeat the fried rice. How much is now? 8 times 8. A noodle is 7. 3 cold drinks. Cold drinks is 10, 10, 10 times 2 hot drinks, 9, 9. So if you do this, you will have 362880000. That much of food, that much of option you have. Order either 2 fried rice. Order either 2 fried rice. 8 times 8, or means plus. Plus 3 noodles and n is the one you put a multiplication. You order either 2 fried rice or 3 noodles and either 2 cold drinks or 2 hot drinks. You press this, you will have 7 3. So this is regarding the sum principle. This is how we use sum principle and what you call the product principle. Now this principle, now we are going to put some condition. Just now we have computing principle. This computing principle we see sum and product. Now we are going to put some condition. Sum and product going to go through some condition. What condition is this? Order, aturan, arrangement, and replacement. Penggantian, order and replacement. When we go through this condition here, we're going to have 4 types of counting rules. Just now computing rules, now counting rules. Huh? We're going to have 4 types of counting rules. One is sample, one is permutation. This is the one you learn in the form 5 there. Another one is combination. Another one, there's selection. Okay, selection. We will focus on this sample, permutation, combination. Basically we're going to focus permutation, combination only. Okay, so let us go through one by one. Sample is the easiest one. Counting rules. Just now computing rules, now counting. Suppose sample, we are in sample now. Sample. Suppose you want to choose a 4-pin code for your debit card. Okay, you want to choose 4-pin code. You want to choose 4-pin code. Each digit can take number between 0 and 9. How many digits are together? 0 to 9, how many digits? 10 digits. Suppose you want to choose a 4-digit pin code. From where you have to choose? From this 10 digit. You're going to create 4 pin code. For example, 1, 2, 3, 4. This is 1. Okay. What is the maybe second one is 1, 1, 1, 1. You can repeat. You can replace. Okay. That's what they mean by replacement. You can repeat. In this sample, you can repeat. Before that, maybe I can put here some another rule here. Copy this one. Easy for you to remember. As I told you, we have 2 conditions. We have 2 conditions. First condition is order. Second condition is replacement. No order. When I say no order, bermaksud kalau if you arrange 1 2 and 2 1, both are one arrangement, both are one, both are considered one. Bermaksud dia punya posisi tak penting. Okay, 1 2 and 2 1 are both are same. As long as you have this number and you have this number, both are considered one. Okay, that is what you mean by no order. This one order. In this case, if order is important, means this is different from this one. You have how many? 2 now. This is 1, this is 2. 1 2 and 2 1 are two different arrangement. Okay, you have to understand that. No replace. This is replace. Replace means you can, if you just now, let's say you want to choose 4 pin, isn't it? If you use number 1, you cannot use number 1 anymore. That is no replace. Replace means you can repeat again number 1 1 1, something like this. Okay, this is one pin code. If you already use 1 and they say no replace, you cannot use the 1 anymore. You have to use other numbers. That is called no replace. Now, as I told you, counting just now, counting rule, we have 4. Okay, sample, there is order and there's replacement. That is sample. Permutation, order is important, but you cannot replace. Okay, permutation, no replacement, which means you cannot use one number more than once. But order is important, arrangement. Combination, no order and no replacement, and selection is replace, no order. We will see more on this one and this one. This is our aim. Combination, permutation is our aim. You want to copy this somewhere, you can copy first before I explain further. Maybe some of you still don't understand this one, but when we go through the examples, I will come back, relate back with this one. Okay, now as I told you, you have to choose 4-digit pin for 4 numbers. So let's say the first number is here. First number for the first digit, how many options you have? 1 2 3 4 5 6 7 8 9 10. 10 you have 10 numbers. So first, for the first digit you have 10 numbers. Okay, I just put, so first digit you have 10. If you put the tree diagram, you can start with 1 0 2 3 4 5 6 7 8 9 10, isn't it? So you have 10 option. I put 10 here. And then for the second digit, for each number here, for let's say just now I put 0 here. If I choose 0 for the second number, how many options I have? Again another 10 for each one of them. 10. So this is only for 1. So just now we have 10 here, and then multiply with another 10. For third number also 10. For fourth number also 10. So basically that's why I write like this. Okay, so how to see this instead of writing a tree diagram? Okay, instead of writing tree diagram, okay, let me explain this. Let me explain this again. Let's say suppose you want to choose 4-digit pin code. Okay, you want to choose 4 digits pin code. Okay, each digit can take the number in between 0 and 9, but for my explanation now, I don't want to take 0 to 9. I just want to take 0 1. Okay, for my explanation. Later you can see the whole picture with the things. Now for first digit, how many number are there? 0 1. Okay, 0 1. For the second digit, if I choose 0 for the second digit, I can choose another 0 1. And if I choose 1, I can choose second digit 0 and 1. And for the third digit, I can split this some more 0 1 for third digit. Can you see how it expand? See how it expand? So how many are there? 1 2 3 4 5 6 7, now 8. For the fourth digit, I can expand some more. So all together, for me to get how many options are there, what I do? 2 times 2 times 2 times 2. All together I will have 16. Yes, no mistake. Yeah, I will have 16 arrangement. Okay, if you choose 0 0 0 0, this is 1. Okay, 0 0 0 0 1, and then 1 1 1 1, this is 2. 2 cannot, because we are only choosing at 0 1. Maybe 0 1 1 1, this is third. Like that, how many arrangement you have? 16 numbers you will get. Okay, can understand, that's the idea. Now if you notice here, as I told you earlier, sample is order is important, replacement can replace. When I say can replace, you can repeat the same number again and again. You can reuse the number for sample. And order is important. What I mean by order is important, 0 1 1 1 is different from 1 0 1 1. Even though it has 3 1 and 3 1 here, both are different. Order is important. Okay, susunan penting dekat sini. 011 dengan 1011 adalah dua benda berbeza. Okay, that's what I call replacement and order is important. That is sample here. Ini contoh, this is an example I took from 0 and 1. The same thing you can do for 10 digit now. Okay, 10 digit means what I do here, 10 times 10 times 10 times 10. How much you get? 10,000. Like this you have 10,000 arrangement. Okay, that's how it goes. So normally what we do, okay, normally we do like this. Suppose that you want to choose 4 digit, put 4 placement like this. Each digit have how many option? How many here? 10 digit. Okay, so put 10 digit. It's not that 10 digit go inside here, only one digit goes inside here, either 0 or 1 or 2 or 3. But how many pilihan, how many option can go here? 10. Okay, this is 10. Now second number also can take 10 option, 10 option, 10 option, you multiply and you will get 10,000 for sample. This how we do for sample. So basically the formula for sample is n times r. N is the distinct object. Just now we have 0, 1, 2, 3, isn't it? Out of 0 to 9, how many we want to choose? 4. 4 numbers we want to choose. Okay, out of 9 we want to choose 4. This is the idea. 10 to the power of 4. Okay, out of 10 object, okay, when they give you certain things, you choose from them, like 8 calculator. From 8 calculator you choose 8 different calculator, you choose 3 means then 8 to the power of 3. How much you want to choose? How many 3-letter codes can be formed if the letters can be repeated? So how many alphabets are there? A, B, C, D. A, B until Z. How many altogether? 26. Out of 26 letter, we want to choose 3-letter codes. We want to create a code, maybe A, B, C, A, or B, B, B. Like this, how many we can create? How many code we can create out of 26 here? If we follow the formula tells you that 26 power 3. Out of 26 we want to choose 3. So how much is this? 17576 you will get, which means A, B, C, D, E, something like this. How many arrangement you can have like this? 17,576 arrangement you can have like this. Okay, instead of using this formula, I still prefer my method. We want to choose 3 letters, isn't it? I put 3 here. For each position here, what is the option for the first letter? You have 26. What is the option for the second letter? Also 26, because we can repeat, we can use the same letter again and again. This one also 26, you multiply all, you get the same answer. So I prefer this method compared to the formula. Now, as I told you, sample is order is important. Okay, order is sample is what I told you. Sample is order is important, and you can replace, you can repeat. Okay, replacement means you can repeat the same letter. For example, just now A, you can repeat, and the order is important. A, B, B are two different things. Even though you have 2A here, 1B and 1B here, this is two different arrangement. Okay, now here goes the second one, permutation. What does permutation tells you? It is same with sample, but you cannot repeat anymore, which means A here, once the first letter take A, you cannot put A here anymore. You have to put another letter. Okay, another letter, which means for permutation, for sample we can put 26, 26, 26, but for permutation here we have 26 option. Okay, A to Z can go inside here. one number goes inside here already. Left is how many number? We have to reduce by 1, 25. That is permutation. Okay, for sample we can put 26, but for permutation we have to put 25 here. We have to reduce by 1 because one number is taken here. Like for example a is here already, so you cannot repeat the a anymore here. So for the second digit you only have 25. How about third digit? You have to reduce 1, 24, because two alphabet goes inside here already. Left is 24 only. Hope you guys understand. You cannot repeat anymore for permutation. Sample can. Permutation you cannot repeat. That is here. Order can. No repetition. Okay, no replacement or repetition. That is called permutation. Order is important. Now, this is where the factorial comes into the picture. Okay. Now, before I go on with this, let me go on with one example here. Now, I want from 1 to 3, okay, 3 numbers, from 1 to 3. In how many way I can arrange this? In how many ways I can arrange this? I can arrange this. I give 1, 2, 3. How many ways I can arrange this? 1, 2, 3. That is one arrangement. 1, 3, 2. Second arrangement. 2, 1, 3. Third arrangement. 2, 3, 1. Fourth arrangement. 3, 1, 2. Fifth arrangement, and 3, 2, 1. This is the arrangement. You cannot arrange 1, 1, 2 anymore because 1 is repeated. You cannot use the number anymore because it is permutation. Permutation doesn't allow you to, no replacement, no repetition. Permutation cannot repeat. Order can. Order is important. Susuna still penting, but repetition cannot. So that's the reason we cannot repeat one number anymore. We have to reduce 1. Okay. So this is the permutation. You can see here 1, 2, 3 is different from 1, 3, 2. Okay. Even though it has both numbers are same, but the susunan penting. Okay. The arrangement is penting. After 1 is 2 here. After 1 is 3 here. Two different arrangement here. So we have 3. But this is only for 3 number. If I give 10 numbers, okay, 1 to 0 to 9 is very tedious. Okay, it will take a lot of time for us to arrange one by one. Okay, 1 to 9. So we must have some formulas. So that formula is actually, if you choose, if you are given 3 numbers and they ask you to arrange these 3 numbers, okay, all number 3 number, the formula is 3 factorial. In other words, if they give n number, then the formula is n factorial. For example now I give 1, 2, 3, 4, 5 number and I want you to arrange everything. What are the possibilities? 1, 2, 3, 4, 5. This is one arrangement. Second arrangement may be 1, 2, 3, 5, 4. This is second arrangement. Third arrangement may be 2, 1, 3, 4, 5. Fourth arrangement may be 2, 1, 3, 5, 4. Like this. How many arrangements are there? Like just now for 3 we can do this, but for 5 if I want to do this, it will take a lot of time. So what is the formula? N factorial. That is the formula. How many numbers are there? 5. 5 factorial. Just now we did 120. So like this arrangement we have 120 arrangement are there. Okay, this n factorial is only for if I give you 5, you have to arrange all number, all 5. You cannot choose 4, you cannot choose 3, you cannot choose 1. All 5 you have to arrange. What is the formula? N factorial. Okay. Let us do some exercise. In Science and Maths Society annual meeting, 3 chairs are allocated for president, secretary and treasurer. Okay, 3 chairs. President, secretary. For permutation, do we just pick smaller numbers than yes. If you are given 5, then you have to choose either 5 or 4, 3, 2, 1. They won't ask you to choose. If permutation, let's say they give you 1, 2, 3, 4, 5, they won't ask you to create 6 digit or 7 digit, because if you do that, you're repeating the place. But permutation cannot repeat, isn't it? So cannot. So you're right. Just pick smaller number than according to the question. Depends on the question also. For the time being, okay, before I move further for this one, for the time being, this exercise, what we have done, if I give you 5, you arrange all 5. You choose all 5. All. If I give 3, 1, 2, 3, you choose all 3. Okay, for the time being. Now here, P, S, T. In how many ways they can arrange themselves by sitting in the same. So how many arrangement are there? Okay, I want to arrange all. How many arrangement we can do? 3 factorial, which is 6. Just now we saw that how I did 3 here. Something similar to this one. Okay. To promote teaching habit among students, Mr. Idris donate 5 storybooks for each class. In how many ways these storybooks can be arranged in a book rack? So 5, let's say there are 5 books, 5 different books, 5 different storybooks. How many ways? All the 5 books, given are 5 books. All these 5 books we're going to arrange. Okay, we're going to arrange. Let's say the books are A, B, C, D, E. All these 5 books, we take all the 5 books, we are going to arrange. What is the formula? 5 factorial, we get 120. Okay, we are still arranging all. Whatever they give, we arrange all. We yet to choose 2, 3, 4. No, not yet. Now, next one is the one we're going to choose now. Okay. The number of k permutation given a set of, okay, before I read the whole thing, okay, let me give you an example. Just now I give you 1, 2, 3 numbers, isn't it? And then I choose all 3 numbers to arrange like this. I arrange all 3 numbers. How many arrangement if we have? 6 arrangement. What is the formula? N factorial. Okay. Now out of 3, I want to choose 2 numbers. 2 numbers only. I want to choose 2 numbers only. So this is where we have to choose now. We cannot arrange all. We have to choose any 2 numbers. So what are the possible 2 numbers? I can, since this is only 3, I can do here 1, 2, 1, 3. Again 1, 1, 2. I don't want to put comma. 1, 2, 2, 1. 1, 2 and 2, 1. Remember, both are different numbers. Even though 1, 2 and 2, 1 are there, but when you arrange front and back, it has a different arrangement. And then 1, 3, 3, 1, 2, 3, 3, 2. I think that's the arrangement. If you choose 2 number, these are all the arrangement. How many arrangement are there? 6. All together 6. What is the formula? The formula, you can use this formula. Okay. Given 3 factorial, out of 3, Okay, out of out of three numbers, this is n, this is n, and this is your k. You have to choose 2, that is 6. Or I think in the school you have used this one. In the calculator you can find that NPK, but in the calculator they put NPR, NPR. So but I put K here. Okay, where is in the calculator, this one is above the multiplication button, there NPR, they write. My K here R, both are same. I just put K here, but in the calculator they put R here. So what you have to press this, you press 3, shift, press multiplication button, there is a NPR, and you press, after that you press 2 and you will get the answer 6. Okay, try 3, shift multiplication button, you will have a P there, and then press 2, that is the 6 here you get. So this how we this time given 3 we choose 2 or we choose 1, we don't choose all. Given 3 you choose 3, all means this formula n factorial. Given 3 you choose 2 or less than is this formula. I give you some time to think about it, and then we move on to an exercise. All right, suppose you guys have copied this. Okay, now how many digits, how many 3 digits numbers can be chosen from the digit 1 2 3 4 5 without repeating in any of. Okay, so without repeating, you know, should know that is either, in this case we are in permutation, so given 5 digits we have to choose 3. If you use the form in the calculator 5p3, okay, if you're using calculator 5p3, try to press that 5p3, you should get 60 if you are using calculator. But if you are using the formula, remember the formula, n factorial divided by n minus r factorial. Our n here is 5. Out of 5, how much we choose? 3. Okay, if you press this in the calculator, you will get 60 also. But my most favorite method is this. Just now remember, for sample I told you I have to put a placement like this, okay, and then just now I put 10, isn't it? I put 10, all 10, and I told you this is can repeat. Okay, if you can repeat, you can put 10, and if you cannot repeat, you have to reduce by 1, reduce by 1, reduce by 1, because you cannot use the same number again and again. Once you are used here, then you have to reduce. Okay, for example, just now we have 1, 2, 3. Okay, and then we have to choose 2, isn't it? We have to put 2 here. Now first digit can take any one of the number, any one of the number. How many options you have? 1, 2, 3. So 3 here, any one of the number. Now let's say 1 goes inside here, so 1 no more, you cannot use 1 anymore. How many number you have? Only 2 and 3, so you reduce, only 2 you have. That's the idea. Let's say, remember, this 3 and 2 is pilihan, option. Berapa nombor boleh masuk dalam ni, berapa nombor. Let's say you have 1, 2, 3, but 2 goes inside here. Let's say 2 goes inside here, so 2 you cannot anymore. How many number you can use for the second digit? Either 1 or 3. Again, 2 options. So that's the idea. Hope you understand my idea here. Okay, you have to reduce. So in this case, how many numbers are there? How many placement we need? How many digits we need? 3 digits. 1, 2, 3. Okay, we have to create 3 digits. Out of how many digits? 5 digits. So put 5 here. We have to reduce 1, 4 here. Reduce 1, 3 here. So you will have 60. Multiply on. So this is the method I prefer. Later in tutorial, I will use this method most of the time. This method very rare. The second method I use very rare to use. This one also very rare. For permutation I prefer this method. 7 students qualified for the final round of debating competition. 3 prizes have been allocated for the winners. How many possible are there for the winners to grab the 3 prizes? 3 prizes. So I'm going to do my favorite method. 3 prizes, either gold, 3 prize. They say 3 prize. They never say the 3 prize. 3 prize. They never say which one is thing. Just 3 prize. And we have to choose out of 7 students. 7, 6, 5. Multiply. What do you get? You should get 210. Okay, that is my favorite method. Or if you want to choose your calculator, 7p3, you will get 210. You can also use this formula to get 210, but I prefer this method. Okay, before I show you, you try these two exercise first. Karim borrowed 5 storybooks from his friend. He wanted to read any one of the book and arrange the rest in the book rack. Okay, so he want to read, basically he want to arrange 4 books. He want to arrange 4 books out of 5 books because one he want to read for himself. So put here 4, 5, 4, 3, 2. You should get 120. Or if you want to use the formula 5 out of 5, choose 4 for you to arrange. 120 also will get. J. Ismail, a badminton coach, wanted to choose 2 out of his 5 players representing the school as the first single and second single. In how many ways the 2 players can be determined? 2 players to be chosen out of 5 and reduced by 1 for 20 arrangement, or 5p2 you will get also 20. I prefer this method. Try this one, this exercise. a small committee has to be chosen out of 10 candidates to run a community project. In how many ways this committee chosen? If consists of president, secretary, treasurer and member, all together 4. This is 4. So out of 10 I'm going to choose 4. 4, 10, 9, 8, 7 I'm getting. 5040, or if you want to choose the formula also 5040. I prefer this method. How many 3-digit odd number? Odd number means number ganje 5 and 37. If 5 single digit is number ganje, but 37 we see the last number, last digit here. Last digit odd means the whole number is odd. 133 last digit odd. Okay, 572 is the last digit odd? No, it's an even number. Okay, number genap. So therefore the whole number is number genap. So for us to create 3-digit odd number, we have to make sure the last digit is odd. Okay, now out of 1 to 9, 1, 2, 3, how many odd numbers are there? 1, 2, 3, 4, 5. We have to choose how many 3 digits numbers can be chosen there. So 1, 2, 3. We have to choose 3. The last digit must be odd. So we give priority for the last digit first. How many numbers can go inside here? 1, 2, 3. 1, 3, 5, 7, 9. 5 digits can go inside here. Option. Okay, not all the digits will go, but any one of them will go. So we have how many options are there? 5. 5 pilihan, 5. Now any one of the digit goes inside here. Let's say 9 goes inside here. 9 you cannot use anymore. Left is how many? 4 here, 5, 6, 7, 8. 8 you write here. Okay, and then reduce by 1, 7. If you do this, you will get 280. If you want to use formula, okay, for this one, for the first 2 digit, okay, for the first 2 you choose out of 8, you choose 2 first, and then for the last one out of 5 you choose 1. But that is the reason I don't want to use the formula, because sometimes the formula is a little bit confusing. Why use 8? Because one number goes inside here already. Let me explain again. Let me explain again. Why use 8? Wait. Ya, yeah, betul. Sebab nombor hujung yang kita dah ambil tu tak boleh repeat balik. Saya explain one more time in a different manner. Okay, sekarang katakan let's say I take number 1 here. Okay, number 1 goes inside here. Number 1 goes inside here. Ada berapa option? Satu option saja. So number 1 tak boleh. Lagi ada berapa option dekat sini? 8. Sebab tu 8 dan 7. Okay. Ini adalah satu option 8 8 times 7 times 1 you have 56. This is 1. Okay, 156. I put here 56 or let's say now I put 3 here. Berapa pilihan? Nombor 3, satu pilihan saja. Nombor 3 saja boleh masuk sini. Sekali lagi ada 3 tak boleh. Nombor 3 tidak boleh guna lagi. Cannot repeat anymore. So how many numbers left? 8. 8, 7. Reduced by 7. So you get 56. Another 56. Add. Or how many times I can do this? For 1 and 3 I have done already. If I do the same thing for 5, 7 and 9, I'm going to have another 56, another 56, another 56. 5 times 56. Okay, that's why just now I write 1, 3, 5, 7, 9. I put 5 here. That's why I put 5 here. Any one of the number, let's say 7 goes inside here. 7 goes inside here. Left is 1, 2, 3, 4. Here you have 4 some more, and then you have 8 here. That's the reason. Okay. Now next one. I no mind if you still don't understand. Later after we have tutorial, we will have tutorial. You can ask me tutorial, or if you want to see face to face after you guys come back to UTSM, you can always ask me. In how many ways we can permute the letters of the word? Now we are going to do permutation. How many letters are there? 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. The 11 letters are there. 11 letters. 11 letters we are going to permute. Remember what is the formula just now? 11 letters we are going to permute. All letters we are going to permute. That would be this one, n factorial. If we choose out of 11 letters, we choose, then this formula, this is the formula we choose. But if I want to permute all the letters, that is 11 here. So what we do? 11 factorial. I'm going to arrange all the letters, but if you see any same letter, do you see any same letter here? You have I. How many letters are there? 1, 2, 3, 4. 4 I. How many S are there? 1, 2, 3, 4. 4 S are there. How many P's are there? 1, 2. If you see repeated letters, if you see something repeat or same, equal, you divide by that factorial. Okay, so I'm going to divide by 4 factorial. Any other repetition? 5. S here, 4 factorial, and then P is 2 factorial. If you redo this, your answer will be 3, 4, 6. So if you see anything any letters, any numbers, any books are same, you divide by that number of factorials. Okay, we have exercise here. How many permutation can be chosen? Okay, or I'm going to arrange all here. Here we have 6, 6 factorial. 6 means 1 2 3 4 5 6. Any same letter, 2. A is 2, 2 factorial. B, 3 factorial. Divide, you will have 60 here. Number 2, how many letters are there altogether? 1 2 3 4 5 6 7. 7. 7 divided by O, how much? 1 2 3 4. R, how much? 1 2 3. Can you try C D E F? No, try C D E F.
Eight.
For C here, you should get 8. So this one is 6 to 6720. For statistics here, 9 factorial. This should be your answer. And we go for next slide. Those don't get to copy this, later I'll say share everything. A librarian wanted to arrange five similar, so this is the same book, same book. Five similar pure maths, four similar mechanic, three similar statistics in one row. Find the count of possible arrangements. So altogether how much? 5, 5, 3, 4. 5, 3, 4 is basically 12. Divide by the similar book. 5 pure books, 4 mechanic and 3 statistics. We will have 27720. This one, hold on for a while. Okay. I believe that I have done some correction here, but I forgot to done the correction here. This one, hold on, don't do yet first. This one. Let me relook into. I forgot to change here. I done some. There is some correction here. I forgot to do here. This exercise, hold on for a while. Okay, last one, combination. We have combination and we have selection here. The selection we don't focus because this is just later. We have time, we focus. Our focus is on permutation and combination. Okay. Okay, now let us finish combination. Combination is the easiest one, very easy. The same thing, this one is in your calculator. You can see out of n, you have to choose k. In your calculator, just beside the multiplication, there's a division. You can see NCR there. Our k is r here. Okay, that is the calculator. And for formula, this is the formula. But I'm going to give an example first. Remember just now we give 1, 2, 3. Okay, out of 1, 2, 3, I want to choose 2. Choose 2. Choose 2. If permutation, okay, I'm going to give example here. Remember, for permutation, when we do we choose to, what is the arrangement here? Let me look back. Okay, permutation. What are the arrangement? 1 2 2 1 1 3 3 1 2 3 3 2. Now, for combination, as I told you, combination here, what is the thing? Remember this one, combination, no replacement, no order. So now order is not, okay, susunan tak penting. Susunan tak penting. Just now permutation, susunan penting. Permutation, the order 1 2 and 2 1 are different, but for combination both of them are same, 1 2. Okay, as long as this is, as though this is in a bag, 1 2 dalam satu bakul. As long as, let's say, one is apple, two is orange, as long as you have one orange, one apple, that is done, finish. Okay, you tak susun, you masukkan dalam satu bakul. Yang ini 1 3 3 1, 1 3 and 3 1 now become 1. Susunan terpenting, and 2 3. So this is the grouping, we call it grouping. Okay, combination, susunan, order is not important. 1 2 and 2 1 basically are 1. As long as you have the number, you have the number 1 2 and 2 1, you have the number 1 and 2, okay, just nice, that is 1. This is, so in this case, if you press in the calculator 3C2, you will get 3 1 2 3. This one I prefer to use the formula, the 3C2, because I cannot use like this, because order is not important. Combination tak ada susunan, tak ada. So saya tak boleh buat macam ni. I have to use the formula here. In how many ways? For perfect, for prefect. Okay, in how many ways? For prefect pengawas can be chosen from 10 candidates. 10C4, you will get 2 1 0. Okay, for combination I use this C, the formula here, calculator one. A school badminton team consists 8 students. In how many ways can we choose a team of 2? So 8C2, 28. A tennis team consists of 4 males and 4 male, 3 female was chosen from 7 male and 5. How many ways? Okay, out of 7 male I choose out of 7 male I choose 4 male and n means, remember, multiplication. Out of 5 female I choose 3 female. So if you press in the calculator, you get 350. So this is just selection. We just choose. We just choose how many we want. We don't arrange. We don't susun. Kita tak susun. Kita pilih saja. Eight dots were plotted with the condition that no 3 dots fall in a straight line. Find the number of triangle. For you to create a triangle, how many dots you need? 1 2 3. That then only you can create a triangle. You need 3 dots, huh? So let's say there are 8 dots. 1 2 3 4 5 6 7 8, something like this. Okay, you have 8 dots here. Out of 8 dots, how many triangle you can do? Like for example, this is one triangle. 1 2 3 4 5. So how many triangle you can do out of these 8 dots? Basically you have to choose out of 8 points there. For you to create a triangle, how many points you have to choose? 3. You have to choose 3. So out of 8 you have to choose 3. How many triangle you can create? 56. Why use multiple? Because they want n here. 4 male and 3 female. A team, one team, satu pasukan adalah 4 male and 3 female. N means saya beritahu multiply. Two parallel lines, okay, garis selari, two parallel lines with some dot plotted on the, in first line there are 2 dots, in the second line there are 8 dots, 1 so second line got 8 dots, the first line have 2 dots, huh? Find the number of triangle can be formed. Again, triangle, how many dots we need? We need 3 dots. Okay. So let's say out of these 2 dots, for me to create a triangle, I can create like this. I choose 1 dot out of the first line and 2 dots out of the second line. Okay. I choose out of the first line, which is out of 2 dots, I choose 1 dot, and n means plus, n means times. Out of 8 dots here, I choose 2. Okay, be careful. I mean, make sure this is 3. Out of the first line, you have 2 dots, isn't it? You choose 1, and second line you have 8 dots. You choose 2. Okay, to create a triangle. Or you can choose two dot. Okay, you can choose 2 dot in the first line, 2c2 multiply 1 dot in the second line. That also will give you 3 dot. Okay, these are the 3 things. Now if you press this in the calculator, what do you get? you will get 64. Right, last one, last exercise. Last exercise for this class. Five teachers selected from 8 male, 5 female to perform duty in an examination. In how many ways these 5 teachers can be selected with the condition that males, you have to choose 5. You have to choose 5 out of 8 male and 5. Okay, you out of 8 male and 5 female, you have to choose 5. Okay, that's the idea. But there is a condition. What is the condition? Males exceed females. Okay, you have to choose male exceed female. So let's say I put a male exceed female. I put male here, female here. I need to choose 5. So what is the possible option here? I can choose all male, 0 female, exceed male mesti melebihi female. I can choose 4 male, 1 female, 3 male, 2 female. Okay, that is the option. Supaya male lebih besar daripada female, so that male is greater than female. Okay, so let us write the option now. I'm going to write this one now. 5 male, 0 female. Out of 8 male, I choose 5, and out of 5 female, I choose 0 female. Or 4 male, 1 female. Or atau 3 male, 2 female. If you do this, you will get 966. So for section 5, we will have a tutorial at 4 today. Section 5, I'll see you at 4 p.m. and you guys can try this one. Okay, this one you can try. There is how many? 1, 2, 3. So you can try. Selection, no need to try. We hold on for a while. This one I just put it here, but in case if you have time, then we go through. Test and exam, I don't think so it is covered selection. If you have time, then we can go through that one. For section 5, you guys can try this. We will discuss this in the tutorial, this one. Okay, for section 6, I will see you all at 6 o'clock. At 6 we have a tutorial at 6, section 6, because I need to replace you one class. All right, so that's it. That's all for today. I'll see you guys in our tutorial. Okay, take care then. Bye.
Alright.